if anybody out in the audience wants to start off, we'll go ahead and start. If you got some burning questions, we'll start with. I think, yeah, go ahead, Ralph.
Might as well start with a question.
Sure.
This is for Tim. You mentioned the Unity software, and I thought that was a gaming engine.
It is.
Can you talk a little bit about why it fits as a digital twin?
Yeah, it's more of a visualization engine that you'd plug the simulation engines into and feeding either live or canned or even synthetic data. I will say that I'm of a strong belief, and I think we've kind of run this to ground within the company, that the digital twin precedes it's the firstborn of the twin always. That we use it to do a lot of design validation, a lot of what you call virtual prototyping, that kind of thing. And in that scenario, you might feed it with synthetic operational data. We do that quite often, but using Unity as the underlying technology for that engine really gives us the visualization layer that we then plug in the models, the simulations, the live data that kind of creates the construct around those visualizing that complex data.
Go ahead.
Hi, Lee, I was just curious, at the end you said, what did you use in order to help to get that 12-hour notice, is what I believe?
Does this work? Is this one on or no? I can talk real loud. So we used, it's a device from EI3, the Symphony device. It does monitoring of the vibrational analysis on the machine. So that bearing was actually about 40 feet from that sensor. So, but it's on the same machine frame, so we can use that to, and then that's why we are looking to put two sensors on, so we can look at machine, essentially strength of signal to find out where the bearing is, and be able to more quickly analyze the problem. Yep. If you talk to, well, Chad's probably a better person to answer, or Stefan.
It's an acoustic sensor. We actually have one as a demo unit out in the area over there. We're doing some simple demos showing both a bearing vibration, a good one and a failed one, and then also a little simulation with dice. So if you'd like to see how that all works out, we have a working demo of that. And it all feeds back into our app, where you're able to set up alerting, alarming, different notifications for someone to be made aware of when there is a potential failure about to happen.
And kind of making my point earlier, we're more similar and different. We do a lot of that kind of analysis on a number of our platforms as well, like helicopters as an example, kind of doing vibration analysis for wear indicators and things like that. So a lot of similarities.
Absolutely.
Yeah.
Yeah, I had a question for Ibrahim. So digital twin tends to be a overhyped term, so to speak, with lots of different meanings. How did you get your executives to understand what you were talking about and understand the business case of why you should move forward with digital twins?
We'd all love to hear that. It's a very good question. I didn't use the word digital twin. No, I'm serious, right? So if you watch my presentation, the narrative that we start with is what is our digital transformation vision, right? And what is that value proposition of that vision, right? And working backwards from there. And then the digital twin is the enabler of that vision, right? So to me, digital twin is not this single sexy toy that you call a digital twin. To me, a digital twin is really a data model that represents the aspects of your physical plant in a virtual way, so that you can get your use cases built, so that you can get your insights done, and all that has value attached to it that you can demonstrate how it ties to a vision, right? And that's the approach we've taken. Now, a lot of people, ask or question, so how do you convince the leadership in terms of the value and where to invest, right? We spent a lot of time, because if you really talk about use cases, you can literally solve a use case by buying 10, 20, 30 different platforms and tools to do it, right? What you have to get your leadership to do is get believers in a vision, right? Not in incremental value that you're trying to chase after solving discrete use cases, right? And the idea that you want to do it at scale, and the idea that you want to do it as an aggregate of how you change the ways of working in your company, right? I like to use this quote. I don't even know if it's real or not, but like, you know, Henry Ford would asks the people if it's you want faster horses or do you want like a car or a spaceship or whatever, right? So if you really want to have a 10x transformation vision, you need to get people to believe in that vision and then be open to investing in a foundation that allows you to build for today but also achieve the future. And that future has to have a value proposition, right? So I'm not going to my leadership saying, I need money to do a digital twin here, and that's the value proposition. I'm saying I need to do a digital transformation for the company at this value proposition. Here's the roadmap, and here's how a value profile would look like. Here's the initial investments I need to do because I need to lay the concrete for my house, but I'm going to build it like that. But it's not easy.
Anybody else?
So Cognite is represented here, but I know the contextualization of the data is highly complex. Did you think about doing it yourself first and then realize, wow, this is really tough, we should go find somebody? And how did you land Cognite as your partner to do what is kind of the meat of trying to put that digital together? So.
I want to hear this.
Even
really touch up on
Cognite is
that one,
asking me
so.
the same question. Okay, so I would say that we did not try to play around ourselves and how to contextualize, but we recognized that this was something that was not practically feasible for us to do it ourselves. We don't have resources, and we also are a very lean company in terms of people and how we want to do it. So we wanted to go after a capability that will shorten the time to value, right? At the end of the day, you could always go out there, build data lakes, and build everything you want from ground up, right? So our approach was, let's partner with a company that has figured that piece out, allows us the flexibility to model the data that we want, gives us the flexibility to build our solutions and use cases, and grow together to build the next-gen manufacturing facility of the future, right? We did look at a lot of different companies and vendors. For us, a lot of different things were more important. You could, look at very sexy visualizations of 3D models, UI, UX. You could look at softwares that are selling a digital twin in different contexts, different angles. For us, the most important piece is if we can model the data in the most flexible way, and it can be done in the most automated, flexible way so that it can power diverse ways of use cases. That's the platform we want to go with, and that's where we want to put energy in and then build the future.
If I could just maybe extend on that a bit. And one of the things I pointed out in my little presentation there was that the digital twin it's not a new concept. It's been around for a decade or more. Or so Dr. Greaves came up with the notion originally. And it's no surprise that the virtual side of it sort of emerged initially because from the PLM guys, from the CAD and the engineering design tools type, because you had to have a virtual model to begin with. And there's also relationships to the product, not only the product design, but there's a relationship to product test, the classic CAE kind of stuff where you actually test the product through very, stress and FEA and all that kind of stuff. What I think is happened is that when initially the concept of the digital twin sort of started to evolve, that it was really a little bit more focused on the simulation side. And simulation, don't get me wrong, simulation is a huge part of the digital twin today because this is what's really going to drive it. But one of the points that I made also was that you don't have a digital twin with a CAD model or a simulation. You don't have a digital twin until you create a physical product. And that's why the context, the contextualization, and the gathering, the configuration of the data, and then description and defining the data in terms of what do you want to find out in terms of maybe a predictive analysis and prescriptive analysis, sort of like polling, you know. You don't, the first thing you do is you got to write that. You got to ask the right questions to get the answers you want. So it's really important to contextualize that data. So I've seen the trend kind of move from digital twin solution providers would would offer maybe a suite of solutions that would sort of enable a company to go out and maybe implement a project. But what we found out, and what those kind of suppliers found out, especially the big PLM guys and stuff, was that what companies really were interested in was not trying to sell a suite of solutions and it would enable a digital twin project, but let's go out and just identify specific use cases that we can apply this to. Something that is going to, a use case that is causing us, it's a business issue also. You know, it's a cost center that we want to eliminate or we want to improve on and so forth. So right now I would say we're seeing digital twins. We see digital twin projects, but they're based on very specific use cases that companies want to deal with. So I think that's kind of where we're at right now. And so I think that's also the reason why there's more of a shift. I don't know if it's a shift, but more of a shift to the focus on data and the importance of data to the digital twin in that contextualized and configurization mode.
So I'd like to add a little more about partnering. We're a company like American Packaging. Their focus is making packages. They've done it for 100+ years. They're really good at it. And they should be focusing their attention on what they do well. Taking on a digital twin data project is not a strength of the company. So by partnering with a company like EI3, we're able to take that on and they can focus on what they do best. And they also gain the benefit of feedback we get from all our customers. So as we start to get data in from customer A, B, and C, we're able to build out a more robust and complete system so that Lee is benefiting from suggestions and improvement ideas from other customers. So, you know, when you're partnering, you're really bringing in the experts. You're not trying to do it yourself. When you do it yourself, it may work in one facility, one type of machine, one piece of equipment, but it does not scale as well because you're not thinking of all the different use cases. There's different ages of machines, the controllers, and different equipment tied to these machines. So, we think the partner approach seems to be happening more and more, and it seems to be a good way to handle the situation and allows you to get a head start on your competition because your partner has done this before and can be able to start you at 30-40% up rather than starting from ground zero.
Yeah, I got to pile onto that a little bit. I mean, we have just so many bad examples of not following that advice. We're currently in the middle of re-architecting our entire ERP system and consolidating it. Over the years, we had deluded ourselves into thinking we're brilliant enough to add all kinds of features onto our ERP system. And that turned into 18 million lines of code that we wrote and we had to maintain, and then suddenly became technical debt as we wanted to move on. So, anything you're thinking about doing in-house, you got to really think about, do you want to own the entire life cycle of that solution as all the interfaces around that change? Because, as we're talking about here, these tools don't exist in isolation anymore. They're part of some digital thread. And so you're not just going to maintain that tool, you're going to maintain everything that it talks to. And do you really want that maintenance tail? And as it turns out, it became an anchor for us. So we actually got a directive from our CEO that we're no longer allowed to modify COTS. Now you can take that to the extreme, but what that means is you can extend COTS through APIs, but you're not adding glue code that Lockheed Martin brilliantly wrote that we then sink to the bottom because it becomes an anchor. So I share that lesson learned with you, and hopefully think about it and you're doing your math on whether you do it internal. Do you really want to own the entire O&M tail for that solution? And probably not. Well, we can't wait to get rid of that.
Yeah, so I can also add from the other side of the partnership as well, especially the wild ride that we've had with Celanese in the last year and are continuing to have on the scaling of their digital plant of the future. We also look to companies like Celanese to help us build better our products. So we're really co-innovating with them to build out the digital plant, and we have a number of other customers, especially in our manufacturing space, that we're working with as well to help inform what our product is going to do in the future. So hearing that voice and hearing what you all have to say really helps us as a company as well, as we continue to service the industry. So the other side of partnership.
And to Chad's point, we would not have, we had people in company that wanted to try to do it themselves. And part of what we talked about was we could capture the data, but we would then have to come up with a way to present. We would then have to come up with a whole quality system based around it. We don't get to use their quality system, we need to build our own. We would have to come up with a whole recipe system around it. We would have all of the things that are already pre-built that we could simply just take and start using. We now have the development time and beta testing of everything that they already have ready to use for us. So it made sense. We tried it in one facility and then moved it across to the rest. It made sense to stay that course versus like, well, let's go a different direction and see how we do.
So we still have a few minutes for questions. If anybody's got anything they want to add on, or we're almost there. Okay. Then I guess going once, going twice. Okay, we'll wrap it up. So thank you all so much for attending. I think this whole digital twin thing is really a journey. It evolves like technology always evolves, and there's a lot of enabling technologies along this journey, and it's going to get much more interesting. And it's also going to get really interesting as we start to apply much more AI and to the systems themselves and what they'll be able to do. So the journey is condition monitoring, maybe, then to predictive analytics, prescriptive analytics, and self-healing, and then ultimately that road leads to a complete autonomy. And so, although I may want to wait a while before we have the vehicles on the road yet, but the factories and the plants and the facilities are definitely heading to that stage of autonomy. Thanks.